Modeling with inequalities. Just as we've worked with many real-world problems with linear equations, okay, there's plenty of situations that require the use of an inequality. So example 1 says, a school is taking a field trip with 195 students and 10 adults. So I always like to highlight our important information. 10 adults. So we've got 205 people that we have to transport. Each bus can take 40 passengers or 40 students, okay? We should say 40 passengers. We need to determine the smallest number of buses needed for the trip. So the smallest number we're looking for. So using a guess and check method, okay? So just doing a little mental math, play with some numbers, in other words. Determine the minimum number of buses needed. Show evidence of your thinking. So that means show your work, show your guesses. So if we tried 4 buses, let's see, would that be able to transport everybody? I think I spelled buses wrong. Are there 2 S's in there? Not sure. Anywho, so if we've got 4 buses, that's not 2. There's not 2 S's in there. I know you guys are probably laughing at me right now. We're just going to say 4 buses, and I'm just going to write bus because, I don't know, it's just not looking right, that S-S-E-S there. So, and we have 40 people per bus, right? So how many people does that transport? That's 160. Are 4 buses going to be enough? We have 205 people to transport. So we're going to say no, 4 buses isn't going to work. So now let's try 5 buses. Let's see if that does it for us. All right, so if we do 5 times 40 people per bus, maybe I should just stick to letters here. What does that give us? That gives us 200. Okay, is that going to work? We've got 205 people, so again, that's no. Obviously, we're almost there, so we know we're going to have to take 6 buses. All right, but then to show that, we do 6b times 40 people per bus, and that gets us 240. Yes, that's over our amount of people that we have, that 205. So we're definitely going to need 6 buses. Okay, so that's showing our work, just doing some number crunching. So it says, let n be the number of buses taken on the trip. Write and solve an inequality that models this problem based on n. Okay, so we know 40 people times the number of buses has to be greater than or equal to our 205, okay, the number of people. So if we take that and we solve it, pretty simple, okay, n is greater than or equal to, we end up with 5.125. So that looks at n has to be greater than this. So we can't take, okay, it's not possible for us to take 5 buses, and we can't take 0.125 of a bus. Think about the context of this problem. So we would need any number of buses over 6. Okay, 6 and over, I should say. Buses 6 and over. Okay. All right, so let's take a look at exercise 2. So our key words here with our inequalities are at least and at most. So I go back to an example when I'm talking about at least and at most. And your mom's made some cookies. Okay, so let's write this down at the bottom, because I'll have a little bit more space down there. Your mom's made some cookies. So at least and at most. She's made a dozen cookies. Okay, so we've got 12 cookies here that we're talking about. And before she leaves the house, she tells you you can have at most 3 cookies. So what does that mean for you? that means you could say, okay, fine, I don't want any cookies. Maybe I just want one cookie. Maybe I want two cookies. Maybe I'm going to go with the max, at most 3 cookies. Okay? So what if, okay, she's feeling so generous and says you can have at least 3 cookies. At least 3 cookies. Wow. Okay? So that means you could have 3 cookies, you could have 4 cookies, you could have, whoops, I don't know what's going on with my stylus. You could have all the way up to 12 cookies. Okay? So that difference between at least and at most, there's a big difference. Okay? All right, so now let's take it and let's translate and work with us. Okay? So we're just going to translate, but they're saying do not solve. Right? 3 times a number is increased by 12. The result is at least, okay, at least greater than, I don't know what is going on with my stylus, and I totally apologize. At least greater than or equal to 32. I'm going to pause this and see if I can get a handle on what's going on with my stylus. Okay, letter B. The sum of 2 consecutive even integers, n and n plus 2, is at most 8. So we've got to sum those 2 integers, n plus 2, and is at most less than or equal to 8. Okay, so there's that difference between at least and at most. It says, find all numbers for which 5 less than 1/2 the number is at least 7. All right, so there's our information that we need to work with. 5 less than a number is at least 7. So, I'm sorry, less than half a number is at least 7. So 1/2 n, remember that less than means we need to switch the order in which it's written, okay, in English, is at least greater than or equal to 7. Then we take and we solve that, add 5 to both sides, we end up with 1/2 is greater than or equal to 12. Oops, let me squeeze that n in there. Again, guys, I'm writing and I can't see where my stylus is going. Times 2, see if I can pick it up again, there we go. Times 2, we end up with n is greater than or equal to 24. Okay. Let's go down here to this last one on the page. Find all numbers such that twice the sum of a number and 8 is at most 4. Twice the sum. So twice, 2, the sum of a number and 8 is at most less than or equal to 4. So distributing, 2n plus 16 is less than or equal to 4. We'd subtract our 16, and we end up with negative 12. Divide by 2, n is less than or equal to negative 6. Okay? So just playing around with it. No application so far. So let's flip the page and let's look at some application of this. Okay? So this one I thought was kind of interesting. Stadium is filling up with people. It holds at most 2,500 people. Of those seats, 350 are reserved for special guests. When the door opens, people fill in at a rate of 10 seats per minute. So if M represents the number of minutes that have gone by, fill in the following chart. So at 1 minute, okay, we've got 1 minute has gone by. We've got 1 times 10, because every 10 minutes, or every 1 minute, 10 seats fill up. So we have 10 that are filling up, plus that 350 that are reserved. So that gives us 360. Then after 5 minutes, 5 times 10, okay, which is 50 seats are filled up, plus the reserved, 400. 50 minutes have gone by, so almost an hour. 500 seats, okay, plus the reserved gets us to 850 seats. Now after 100 minutes, so almost close to 2 hours, we end up with 100 seats, 1,000 seats have filled up, plus our reserved gets us to 1,350. Okay? So it says write an expression. Okay? An expression doesn't have an equal sign, doesn't have an inequality sign, that calculates the number of seats filled and reserved in terms of minutes M that have passed. So 10 seats per minute plus our reserved. Okay, so there's our expression. Okay. Now it says write an inequality that shows times in minutes before the stadium is overfilled. Solve that inequality. So we have 10 seats per minute plus our 350 reserved has to be less than or equal to that. Okay, less than or equal to how many people can fit in our stadium. All right, I'm going to take this and bring this down and just give you the answer to that. We know subtract 350 from both sides, divide by 10. Okay, so our minutes has to be less than or equal to 215. Okay, so a little over 3 hours. At the rate that people are entering, will any more people be able to find a seat after 4 hours? So I kind of just mentioned that in part C there. So it says justify yes or no. So if we end up with 4 hours, okay, which we know is 60 minutes, okay, we end up with 240 minutes. So let's go back to our question. Will any more people be able to find a seat after 4 hours? No. Okay, because at 215 minutes, the stadium's going to be filled. Okay. And the next part says, to cover the cost of the stadium, labor, and other overhead costs, stadium organizers must raise at least $39,000 from ticket sales. At least. Okay, so that or more has to be raised. So let's see what other information they give us. It says if tickets sell at $25 each, will they have covered the cost if 1,250 tickets are sold? So we know that's how many tickets are sold times $25 a ticket. What is that going to give us? That's going to give us $31,250 just from ticket sales. So are they going to be able to cover their costs? No. Okay, because what do they need to cover their costs? They need that $39,000, and we're short. Okay, last piece. Let n represent the number of tickets sold. Write and solve an inequality that represents all values of n that guarantee the organizers will cover their ticket sales. So we know $25 times the number of tickets has to be greater than or equal to our overhead costs, that $39,000. Okay, and we divide by 25. We need to sell 1,560 tickets or more in order to cover that cost. So if that's the exact amount of tickets, we're going to make that amount of money, that $39,000. So obviously it would be best case if we could sell more than that. All right, nice job, guys.